Hello students. So this is the third lecture wherein we are dealing with the chapter probability, which is chapter 16. Now in the first two lectures we have dealt with the sample space and we also have defined the events. We have also defined what is a mutually exclusive event and what is an exhaustive event, and we have solved all the problems given in the first two exercises 16.1 and 16.2, and here we will deal with the few basic concepts of probability and straight away start by solving the problems given in 16.3. We begin with the axiomatic approach to probability, which is very simple. Now consider S to be the sample space of a random experiment. So we have observed a number of random experiments, maybe tossing a coin or throwing a die, and we have defined the sample space. Now S is the sample space of a random experiment, and the probability P is a real valued function whose domain is a power set of the sample space and is in the range of 0 to 1, right? So probability of any event occurring always will be in the range 0 to 1. So therefore we define these axioms. Now what are they? Now for any event E, so for any event E occurring, the probability of event E is always greater than or equal to 0, right? So in fact the probability of any event will always lie between 1 and 0. The second one, probability of the sample space is equal to 1. So we define that the event E is a subset of the sample space, and hence the probability of the sample space is equal to 1. And the third one, if the events E and F are mutually exclusive, then probability of E union F equals P of E plus P of F, right? So here we know that probability of E or F or P of E union F equals P of E plus P of F minus P of E intersection F. So this is a formula which you already know, but when the two events are mutually exclusive, this is equal to 0. Probability of E intersection F is equal to 0. So therefore we get this expression P of E plus P of F, and also probability of a null set is equal to 0. Next we define what is the probability of an event E. Now probability of an event E is defined as number of favorable. So how do we define probability of an event E? It is defined as, so how do we define probability of event E? It is defined as number of outcomes which are favorable to the event E divided by the total possible outcomes. So here we define S being the sample space and E be an event where each outcome is equally likely. That means the possibility of we getting each outcome is equally likely. So therefore, in that case, the probability of any event E is given by this expression. Now with these axioms and this expression, we will be able to solve all the problems given in the exercise 16.3. So the first problem, which of these cannot be a valid assignment? So which of these probabilities cannot be valid? Now here, given 7 outcomes, the probability of getting outcome W1 is 0.1, W2 is 0.01 and so on. Now we must remember that given the probabilities of outcomes, the sum of all the probabilities should be equal to 1. So to check if this is a valid probability assignment, add up all of them. So you add up all of them, 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.2 plus 0.6. So this is 0.1. You add up these 4, you get 0.1, and this is 0.8. So the sum is equal to 1. So therefore this is a valid probability assignment. Moving on with the next one, I have 1 by 7. That means all the outcomes occur with equal probability. So if you find the sum, it is 7 by 7, you get 1. So therefore, since the sum is 1, the second one is also a valid probability assignment. So let me just put a tick mark here. The next one, C, the next one, you add up all of them. If you observe these two itself, 0.5 plus 0.6 is 1.1. So therefore this is greater than 1. So sum is greater than 1. So this is not a valid probability assignment. Next, the next one, D, minus 0.1, 0.2 The moment you observe a negative probability, you know that this is not a valid probability assignment, because probability of any outcome can never be negative. So therefore, this is not a valid probability assignment because you have a negative probability occurring here. If you observe this, there is no need for us to add, because we observe that you have 15 by 14, which is greater than 1. So therefore, the sum also will be greater than 1, and also the probability of an occurrence can never be greater than 1. So this also is not a valid probability assignment. So only the first two are valid probability assignments. Second one, a coin is tossed twice. Find the probability that at least one tail occurs. So if a coin is tossed twice, the sample space is 2 heads, a head, tail, tail, head, and 2 tails. We need to find the probability of at least one tail occurring. So therefore, at least one tail means it has to be 1 or can be more. So I have 1, 2, 3. So therefore, probability of at least one tail occurring. So let me call that event as A, where probability of at least one tail occurring is the number of favorable outcomes, which is 3, divided by the total number of outcomes, which is 4. So the probability is 3 by 4. The third one, a die is thrown. Find the probability of the first one prime number. So what is the sample space? The sample space is 1, 2, 3, 4, 5, 6. So what is the total number of outcomes? N is equal to 6. Now first one, we getting a prime number. So let me call that as event A. So what are the primes? 2, 3 and 5. So therefore, probability of A is number of favorable events occurring is 3 divided by 6. So it is 1 by 2. Next, second one, probability of getting a number, let me call that number as X, which is greater than or equal to 3. So therefore, the event B is greater than or equal to 3. So I have 3, 4, 5, 6. So probability of B is number of favorable outcomes, which is 4 by 6. 6 is total number of outcomes, so it is 2 by 3. Next, third one, probability that a number is less than or equal to 1. So if I call that as event C, less than or equal to 1 is only 1. So therefore, P of C is 1 divided by 6. Next, fourth one, probability of we getting an event, probability of getting a number greater than 6. So X greater than 6. So you cannot have any number which is greater than 6. So therefore, let me call that as D, which is a null set. So therefore, probability of D is 0. 0 by 6, or it is 0. The fifth one, probability that a number is less than 6. Less than 6 meaning I have numbers 1, 2, 3, 4, 5. So probability of E is number of favorable outcomes, which is 1 to 5. That is 5 divided by total number of outcomes, which is 6. A card is selected from a pack of 52 cards. A, how many points are there in the sample space? So since there are 52 cards, definitely you have 52 points in the sample space. So each card happens to be a point in the sample space. B, probability that a card is an ace of spades. Ace of spades. So we know that there is only one card which is an ace of spades. So therefore, let me call this as A. So probability of A is there's only one card, one favorable outcome divided by total number of outcomes, which is 52. C, first one, probability of an ace. So we know that there are 4 of them, right? So probability of B is 4 by 52, which is 1 by 13. And probability that a card is black. So out of 52, you have half of them which are black and half of them which are red. So therefore, probability of C is the number of cards which are black is 26 divided by total number of cards, which is 52. So therefore, the probability is 1 by 2. So a very simple problem. Fifth one, a fair coin is marked 1 on one face. So there's a coin. So on one side I have 1 marked. On the other side behind it is marked 6. And a die is also tossed. So you have a coin and a die. Both of them are tossed. Find the probability that the sum of the numbers is first one 3, second one. So when a coin is tossed, I can either get the number 1 or number 6. So probability of getting a 1, so this is for the coin, is 1 by 2. Number of favorable events divided by total number of outcomes is 2. So either I get 1 or either I get 6 when I toss the coin, right? Now probability of we getting a 6 for the coin is again 1 by 2. Next, for the die, the sample space is of course 1 to 6. So I can either get 1, 2, 3, 4, 5 or 6. So what do I need? I toss a coin and I throw a die. So the sum should be 3. So when will the sum be equal to 3? The sum will be equal to 3 when I get a 1 on the coin and I get a 2 on a die. Now when do I get a 2 on a die? The probability of getting a 2 on a die is the number of favorable outcome is 1 because there's only one combination, divided by total number of outcomes is 6, right? So probability that I get a 1 and I get a 2 on a die is probability of me getting a 1 on a coin into probability of getting a 2 on a die. So when I add up both of them, I get 3, right? So you multiply the probabilities, 1 by 2 into 1 by 6, I get 1 by 12. So probability of getting a 1 on a coin and a 2 on a die is 1 by, again probability that I get a 12. So when I add the numbers, I should get a 12. So probability of getting a 6 on a coin is 1 by 2. So similarly, probability of getting a 6 on a die is also 1 by 6, isn't it? So therefore, one favorable outcome divided by total number of outcomes. So it is 1 by 6. So therefore here I need to get 12. That means I need to get 6 on the coin and 6 on the die. So I multiply the probabilities. Probability of getting a 6 on the coin into probability of getting a 6 on a die. It is 1 by 2 into 1 by 6. Again the probability is 1 by 12. Problem 6. A city council has 4 men and 6 women. So one of them is selected at random. What is the probability of a woman being selected? So how likely is a woman selected? So what is the total number of people? The total number of people in the council is 4 plus 6, which is 10. So probability that a woman is selected among these 10 is number of favorable outcomes. So there are 6 ladies here and the total number is 10. So it is 3 by 5. The 7th one is very interesting. A fair coin is tossed 4 times. You win ₹1 for every head and you lose 1.5 rupees for every tail. For the sample space, calculate the amounts of money after 4 tosses and also find the probability of having these amounts. Since the coin is tossed 4 times, there are 16 combinations. If the coin is tossed 3 times, you have 8, but when you have 4 times the coin being tossed, so it varies from head to 4 tails. So there are 16 combinations, right? So we'll try to list them out. So case 1, getting 4 heads. How many combinations do we have? Only 1. So this is the only combination. So the occurrence is 1 by 16. So it only occurs once out of 16. So this is the probability. Probability of getting 4 heads is 1 by 16. So when I get 4 heads, what is my win? Every time a head occurs, I win ₹1. So there is a gain of 1 rupee. But when I get a tail, there is a loss of 1.5. So this is plus and this is minus. So it's going to be 1 plus 1 plus 1 plus 1, which is ₹4. So every time I get a head, it becomes plus 1. And every time I get a tail, there is a loss. So this is ₹4 gain. Now similarly, you have only one combination of 4 tails. Again, this is 1 by 16. So every time a tail is occurring, I have a loss of 1.5. So it's 1.5 into 4. So I have ₹6, which is under loss. The third one, 3 heads occurring. So how many 3 heads would occur? So you basically have 4 combinations. 3 heads and a tail. and then you have head, head, tail, head, head, tail, 2 heads, and tail, 3 heads, right? So 3 heads and 1 tail. So you have 4 combinations. So the probability of this event occurring is 4 by 16 equals 1 by 4. So this is the probability, 1 by 4. So since 3 heads occur, you have a gain of 1 plus 1 plus 1 minus 1.5. So 3 minus 1.5, which is 1.5 gain. So rupees 1.5 is gained if 3 heads occur. Similarly, I have 3 tails. So you have 3 tails and a head. Tail, tail, head, tail. Tail, head, tail, tail. And a head, tail. 3 tails. Right? So again you have 4 possibilities, 4 by 16, and the probability is 1 by 4. So how do I calculate? Since I have 3 tails, the loss is 1.5 minus 1.5 minus 1.5 plus 1. So this is going to be minus 4.5 plus 1, which is minus 3.5 rupees. Or I can say that there is a loss of 3.5 rupees. Next, among 16, how many are over? So here 4 plus 4 is 8, 9, 10. So 10 of them are over. We have 6 more combinations and they have 2 heads and 2 tails. So let us list them out. Head, head, tail, tail. Head, tail, head, tail. Head, tail, tail, head. So you have 3 combinations where at the first toss you get a head, and then I have 2 tails, 2 heads. Tail, head, and a tail, head, tail. So how many are there? 6. So 4 plus 4 is 8, 9, 10 plus 6 is 16. So therefore the probability is 6 by 16, or it is 3 by 8. And what is the gain or loss? So since I have 2 heads occurring, there is a gain of 1 plus 1, and 2 tails occurring, I have 1.5 minus 1.5, which is going to be 2 minus 3. So I have a loss, or I can write minus rupees 1, or there is a loss of 1 rupee. So either you put a negative sign here or say that you have a loss of 1 rupee.